Bismillahirrahmanirrahim. Assalamu alaikum. This lecture is for BBA 2. The subject is Business Mathematics. This is our sixth lecture, which is delivered by Ms. Zahra Arif. In this, we will discuss about the chapter Mathematics of Finance 3, Annuities. Previously, in the last lecture, we have already discussed about the ordinary annuity and three different types of annuities, means ordinary annuity, annuity due, and perpetuity. We have discussed the sum of the ordinary annuity in the previous lecture. Now in this lecture we will discuss about the present value of ordinary annuity. First of all, we need to know that what is the present value of an ordinary annuity. The present value of an ordinary annuity is an amount of money today which is equivalent to a series of equal payments in the future. For example, if a loan has been made, we may be interested in determining the series of payment necessary to repay the loan with interest. Means you have taken a loan and you are interested to know that how much amount you have to pay. So you are interested to know that how now. When you are interested to know now, that is the present value. Now, what is the formula of present value? Here the formula of present value is P is equal to R into 1 minus 1 plus I raised to power minus N divided by I. R is the amount of an annuity, I is the interest rate per compounding period, N number of annuity payments. It's not N number of years. Again, keep it in your mind that this N is number of annuity payments. And P is the present value of annuity. For example, a loan of $94 is to be paid back in monthly installment in 1 year. The first one starting 1 month after the starting of the loan. Now, see, it is written that the first one starting after 1 month of the starting of the period. After 1 month means that at the end of the period. So it demonstrates that this is the question of ordinary annuity. If the interest is charged at the rate of 24% monthly on the unpaid principal, what will be the amount of monthly installment? Now they are asking about the monthly installment. It means that we need to find R. Here P is $94 and interest rate. Look, here interest rate is 24%, but it is compounded monthly, so we need to divide this 24% by 12. So 0.24 divided by 12. And the loan is for 1 year, and in 1 year there are 12 months, so N would be 1 multiplied by 12. Moving forward by putting the values in the formula, in simplifying it, what we get the result that R is equals to $8.89. What is R? R is equals to $8.89. Moving forward, this is another example that find the present value of an annuity. It is saying to find the present value. In the previous scenario, we have judged that is the question of the present value. But in this, it has explicitly said that find the present value of an annuity of rupees $600 payable at the end of each year. Again, at the end of each year means this is the question of ordinary annuity and said the present value, so we need to put the formula of the present value of ordinary annuity. For 15 years, if the interest rate is 5% compounded annually, so the interest rate will remain the same, that is 0.05, and N will also remain the same, that is 15. Now putting the values in the formula, what we get a simplified answer, that is $6,228. So the present value of an annuity which we have to pay in a year is $6,228. Moving forward, now we have come to know about the formula. That what is the formula of finding the present value of ordinary annuity? If we know the present value, then we can find R. If we know the present value, we can also find N. Let's see how is it possible. For example, Mr. Ahmed borrows $21,000 from a bank to build a house with the condition that he would pay back the loan in the semi-annual equal installment in 4 years. Now semi-annual means it is compounded semi-annually in 4 years with interest rate is 6% compounded semi-annually. If the first payment is start at the end of the first 6 months, again at the end of first 6 months, which demonstrate that this is the question of ordinary annuity. What would be the amount of each installment? So again we need to find R. Here P is equals to $21,000. R is equals to nothing, that is X that we need to find. I is 0.06 divided by 2 because it is compounded semi-annually, and N is minus 4 into 2 because 4 years multiplied by 2 because it is compounded semi-annually. By simplifying it, we get the result that is R is equals to $2,991.45, which we say that it is approximately $3,000. Moving forward, this is another example in which we can find N when P is known. For example, Mr. Ashraf wants to deposit his savings of $50,000 in a bank, which offers 8% interest compounded semi-annually, so as to withdraw $2,500 at the end of each 6 months from the date of deposit. How many withdrawals? Now he is asking how many withdrawals, so it means that he is asking about N. How many withdrawals will he or she or his hire in case of his death be able to make before the entire amount is exhausted? So P is equal to R into 1 minus 1 plus I raised to power minus N over I. By putting the values in the formula, what we get? 50,000 is equal to 2,500 into 1 minus 1 plus 0.08 divided by 2 because that is 8% compounded semi-annually, so we need 2 divided by 2. And N remains the same. Now keep it in your mind that he has asked how many withdrawals. He has not asked you about the years. He has asked about the withdrawals. So it means that you just need to find N. You do not need to convert N into something else. By putting the values in the formula, we can see that it has simplified, and 0.8 is equal to 1 minus 1.04 raised to power minus N. It's step number 4. Now what we have done that this N in which the variable is in the power, we have took it to the one side, that is the left hand side, and the remaining constant on the right hand side of the equation. So what we get, 1.04 raised to power minus N is equal to 0.2. Now this is a rule that if the variable is in the power and we need to find the value of the variable, there is simple rule that you need to take a log to find the value. So take a log on both sides. When we take a log on both sides, the equality remains the same. So I am taking log on both sides. By taking log on both sides, we have seen that it's a log rule, that in a log, when the power comes in the beginning of the log. So we can see here that log into 1.04 raised to power minus N is equal to log of 0.2 is equal to minus N. Log of 1.04 is equal to log of 0.2. By simplifying it, N is equal to log of 0.2 divided by minus log of 1.04. By finding the value of log with the help of calculator, I get the value that N is equal to minus 0.6989 divided by minus 0.0170. So here N is equal to 41.11. Moving forward, this is also a question for finding N when P is known. But here what happens, that in this question they have given the down payment as well. For example, Mr. Salim purchased a TV set on installment which required 1,000 as a down payment and installment of 200 per month for 12 months. Now he has to give the 200 installment along with the down payment. So what we will do? We will find the installment value with the help of the formula and we will add 1,000 in that. So here, what becomes the formula? We need to find the cash price of the TV. The cash price is known as the present value of the TV. So the present value of the TV is equal to down payment plus present value of the monthly installment. We have written 1,000 under the down payment and present value of monthly installment is given formula here. By putting the values in the formula, this is for 1 year. So 12 months, 12 months. So we will write 12 in N and interest, what will we do? 12 divided by 12% divided by 12, that will become 0.01. By putting the value in the formula and simplifying it, what we get rupees 3,252. Now I have given you the resource of these slides. At the end of that resource, there are certain questions related to the exercise. You need to solve those questions and send it back to me as an assignment. Thank you.